So whenever we solve trig equations, again, like I said, we're going to break it down and kind of break it down through 3 days. Remember when you have a sine function or a cosine function or a tangent function, remember that certain values repeat themselves in terms of like your y value repeats throughout. You know, if you would think about the unit circle, there are multiple times that your y value is the same, usually 2 out of the 4 places. Same way with sine function with your graph, you know, that you have multiple spots where it fills a certain value. So like usually whenever we look at one spot normally, so or depending on what our period that we're looking for our various solutions. So whenever we find sine of x, like when is it equal to 1/2? Well, in this case, there are multiple places that if we would just continue to draw this thing, because it just reinvents itself essentially, that there are multiple places to where it just continues to go, either forward or backwards, things of that nature. Okay, because everything repeats itself. Same way whenever it's 0, whenever it is -1, whenever it's +1. There are various spots where those same values are going to be seen over and over again. Okay, so whenever we do this, you're going to have multiple spots. Usually whenever we do find solutions, you've got to pay attention to, like, where are we talking about? Like when, you know, when does the period begin? When does it end? So from 0 to 2 pi, in this case, it's going to have multiple answers and multiple values. Okay, that's going to happen a lot of times. That normally it's going to happen over at least once, maybe twice. Usually, depending on unless your period is extended outside of just a regular unit circle and from 0 to 2 pi, then it's usually 2's usually the max, but that's not necessarily always going to be the case. So like it talks about as far as all the solutions, if we go from 0 to 2 pi, basically you add any multiple of 2 pi to each solution set. So since we had pi over 6 and we had 5 pi over 6, you just add 2 pi to everything and you're going to get those same values. Okay, if we would just continue to go out. So whenever we actually solve a trig function, okay, a single trig function, first thing you want to do is try to isolate the function on one side of the equation, solve for the variable, and then describe all the solutions to the equation. So if I have 3 sine of x minus 2 equal to 5 sine of x minus 1, you want to change everything as far as you want to try to get your trig function to one side, everything else over to the other side, just like you would a normal variable. Okay, so if we do this just like we would a normal variable, so again, we treat the sine function basically as a variable and we want to isolate it as best we can. So whenever we do that, just if I would have anything before, I am going to move the 2 over to the other side. So then I have 3 sine of x equal to 5 sine of x plus 1. From here, I'm going to move the sines over to the same side. So I'm going to subtract 5 sine of x. So then on the left side, I'm going to have -2 sine of x equal to 1. Now, what do I need to do to get the sine of x by itself? divide by negative 2. So I'm looking at sine of x equal to negative 1/2. Now, it's completely up to you as far as what you want to move. Like, if I will have some students that will always move the smaller sine, cosine, tangent, whatever trig function they have over to the other side. And that's completely fine. I will have some that will always move the right side over to the left and have the sine, cosine, secant, whatever function on the left side. It's completely up to you, okay, as far as how you do it. So then, if we want to know when is sine of x equal to negative 1/2. So you can do this a couple different ways. The way that's probably going to be a little bit easier for you is if you kind of go back to your unit circle and say, when is it negative 1/2? So when is everything, okay, obviously on this bottom side, okay, because it's going to be, remember, sine is y, so when is your y value negative 1/2? So you can either use that, or you can go off of, like we said here, with your hand. Here's whenever it's a positive 1/2. We need it to be negative, so if it's at pi over 6, we know it's going to be, here at 5 pi over 6 where it's positive, so it's going to be negative. When's it going to be negative then? Seven pi over 6 and 11 pi over 6. If you need to draw out the unit circle, or you need to go back and look at the unit circle, that's fine. Do that. It's completely up to you. Whenever it fits in the window of 0 to pi, 2 pi, excuse me, then 7 pi over 6 and 11 pi over 6 are your solutions. If it asks for all solutions, okay, if it asks for all solutions, then what you're going to do is you're going to take what was just above, where all you're going to say is x is equal to, you're going to take your 2 pi values, so 7 pi over 6, and you're just going to add 2 pi in. Okay, that just basically means, all this means is any multiple of 2 pi. And then I'll do the same thing for the 11 pi over 6 plus 2 in, or 2 pi in, excuse me. But again, all that means is basically that I can just take any multiple of 2 pi and add it to the values that I already have. That's the only time you're going to do it if it asks for all solutions. So if it asks for all solutions, you're going to need to tack on this at the back end. So now on 2, I have 5 sine of x equal to 3 sine of x plus the square root of 3. Okay, what do you want to move? Do you want to move the 5 sine x? Do you want to move the 3 sine x? Do you want to move the square root of the square root of 3? What would you prefer moving to one side or the other? 3 sine x is a good idea. So that's gone. So if I subtract 3 sine x, then I have 2 sine x equal to the square root of 3. Now, just divide by 2. Sine of x is equal to square root of 3 over 2. Again, you can either go to So if this asks for, so there's part of it. So when is this the case? So again, you can, this one's a little bit easier, I feel like, because if you use the hand trick, when is our value square root of 3 over 2? When is the bottom side of my hand have 3 fingers showing? Right here. All right? So pi over 3. So pi over 3, and then the other one that's up on the top side. So remember, again, if you want to use your circle, that just means that it's everything up here. So pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n. If it just asks for the spots between 0 and 2 pi, the only thing you need to worry about is here and here. If it asks for all solutions, you need to tack on the 2 pi n. Now, with 3, it says solve an equation with multiple angles. So we have tangent of 3x equal to 1, where it says that it's going to be from 0 to 2 pi. Now, the one thing that you have to remember here is that pi is a period of 1 pi. Or excuse me, tangent is a period of 1 pi. So it's actually going to have 2 different values. Okay. Also remember that tangent is sine over cosine, so you're going to have 2 different values as far as when it's positive and negative, that it can still fit certain cases. Okay, because it's equal to 1. Okay, I have tangent of 3x. Now, the way that I would set anything up here that you have something you're not accustomed to here is to kind of use a variable for your variable. Okay, so what I would do is make u equal to 3x, so then you can write it as tangent of u equal to 1. What this will do is it'll make it easier for you to figure out, okay, when is everything going to be 1? Okay, because I have all these different values. With the 3x, you really don't want to worry about trying to separate everything out. We don't have any sort of thing called a triple angle or things like that. So figuring out what your values are, and then what we'll do is we'll basically add everything through whenever we have like what we tack on at the end, like the 2 pi n. Okay, we're just going to change that at the end. But if you kind of shortcut it this way, it'll make it a little bit easier. Because when is your angle equal to 1? At what spot? Like if we would have our circle, or if we would use the hand trick, when does the top side match the bottom side? Yeah, pi over 4, right? So what we want to do here, if I have u, I'm going to have pi over 4 plus, now I'm not going to have 2 pi n, but I'm going to have pi times n. Because how long is the normal period of tangent? It's just 1 pi unit, right? The reason why we did this is because now what can I replace for u down here? The what? 3x. Okay. Now I can basically rewrite everything, and I can have 3x equals pi over 4 plus pi n. So how am I going to get x by itself? Divide by so then my angle measurement, or my x measurement, is going to be pi over 12 plus pi over 3 times n. Now, I'm not finished here, okay? Because I'm not finished because at the very top where it says I want to know when is it between 0 and 2 pi. So if it's between 0 and 2 pi, all I'm going to do, if it's between 0 and 2 pi, how many different spots do I normally have? Okay, so basically I'm going to start with 0, and I'm going to let n equal 0, and I'm going to plug that into my equation here. So what's my first spot? If I plug n in for 0, or 0 in for n, what's my first spot? Isn't it just going to be pi over 12? That makes sense? What if I do my first multiple? What if it's so n equal to 1? So what's pi over 12 plus pi over 3? Or what's 1/12 plus 1/3? Five pi over 12. Do the same thing with the second multiple, so times 2. So pi over 12, or 1/12 plus 2/3. I'm going to get 9/12, or 9 pi over 12, which is the same thing as 3 over 4. Basically, I'm going to keep plugging in values for n until I get either 2 pi, or I find a number that's going to be bigger than 2 pi, or 12 pi over 6, or whatever value I'm looking at. In this case, there are 6 different values, because if I let n equal 3, I'm going to have 13 pi over 2, or 12, excuse me. If I let n equal 4, I'm going to run out of room. I'm going to have 17 pi over 12. And then the last one, if I would have n equal to 5, I would get 21 pi over 12. If I go to 6, okay, 6 is going to put me at 2 pi plus pi over 12, so it's going to be bigger than 2. I'm going to do the same thing on 4 as I did on 3, as far as I'm going to take what I have here, and I'm going to change it to where u is equal to, it should be x over 2, not x. So then I can have sine of u equal to when is sine equal to 3 pi over 2? Pi over 3. So I would set each one equal to, so if I have u equal to pi over 3 plus 2 pi n, if I have 2 pi over 3, oh, wrong one, u equal to 2 pi over 3 plus 2 pi n. So since we have a half angle, I'm just going to have x over 2 equal to it. So if I want to get x by itself, I just have to multiply everything across by 2 and go from there. Okay. Now, if it would have just been like sine of x, we wouldn't have had to change anything, and it would have just basically been what was in the green, and we would have went on. The reason why we just did it that way, just so you can kind of see that if you have certain, like if you have a half angle, I'm going to have 2 pi over 3 plus 4 pi n.